Let's take a look at improper fractions and mixed numbers. So I'm going to start out with a mixed number because we seem to be pretty great at mixed numbers. We know that a mixed number is a whole number plus a fraction with a numerator and denominator. So the first thing that we usually try to identify with a mixed number is how many wholes do we have? So in this particular model, I have one hole shaded in here and two holes shaded in here. This model is not shaded in, so I will not count that as my whole number. I have two holes, one here, one there. Next, I'm going to write the fractional amount of the remaining piece. All of my models are split into thirds. This is showing a model of thirds. So my denominator is going to be 3. Lastly, I want to look at this last model and identify how many shaded parts there are out of 3. And I see 1. There is 1 shaded part out of 3 in this model. Therefore, my mixed number is 2 1/3. Now going over to my improper fraction, I am going to use the same model and I am not changing it in any way. An improper fraction is when your numerator is greater than your denominator. Our denominator is not changing. I know that because I have not changed my model. All of my models are still separated into thirds. This is a model of thirds, this is a model of thirds, and so is this. So but my denominator will remain a 3, just like it did over here. The difference with an improper fraction is now I'm going to count my shaded parts. So rather than counting the whole models, I'm going to count each individual piece that's shaded in. 1, 2, 3, 4, 5, 6, 7. So I have 7 parts of those thirds shaded in. Again, my denominator doesn't change because these are each models of thirds, and my numerator indicates the number of shaded parts in all. Let's now take a look at drawing a model ourselves when given a standard form fraction. This standard form is a mixed number, which means I need to show 1 3/8. You guys are rock stars at showing this. So you know that when I'm dealing with this mixed number, 1 3/8, that means that I'm going to have a model that's split into 8s. So I'm going to start by drawing one model, and I'm going to split it into 8s. And I need to show that one whole model has been shaded in. So I am going to shade in one entire model. Okay. And in order to show the fractional amount, I need to draw one more model of 8s. The best I can. I see this one is not split quite as evenly, but you get the picture. And I need to show 3/8. 1, 2, and 3. So now I have a model of a mixed number that shows one whole and 3/8 of another. Now I can take the same model and I can write the equivalent improper fraction. Remember, for an improper fraction, your denominator does not change. Both of my models are models of 8s. So my denominator is going to remain as an 8. Instead of indicating that I have one whole model, I am going to count all of the individual shaded parts. So I know that if I have one complete model, there are 1, 2, 3, 4, 5, 6, 7, 8 parts shaded in. I have 8/8 shaded in here, plus the 3/8 here, 9, 10, 11, gives me 11/8. So again, I have 11 shaded parts out of 8. And up here, I have one whole model shaded in with 3/8 remaining. And again, my denominator doesn't change because each model is split into 8s. Let's do the same thing and draw a model, but this time we're going to start with an improper fraction of 5/2. That means that my fraction model is going to be split into 2 parts. So I'm going to draw my first model. I am going to split it into 2 parts, and I need to show 5 of them. Here is 1. Here is 2. I need to show 5 parts, so that means I am going to draw another model and split it into 2 parts because my model doesn't change. It's always going to be halves. I'm going to continue to shade in until I reach 5 shaded parts. So I had 2 here, 3, 4. Oh, I'm going to need one more model. Again, my denominator is a 2, so I'm going to split that into 2 parts. I have 2 here, plus 2 here is 4, which means I need one more shaded part. My improper fraction shows 5 shaded parts with each of my models showing halves. So this is a model of halves. I can find the equivalent fraction of this improper fraction as a mixed number by now looking at the whole number. How many whole models do I have shaded in? I have 2. And my remaining model shows 1 of 2 parts. So 1 whole, 2 wholes, and 1/2. Or 1, 2, 3, 4, 5 halves. Here's one last example. Again, I notice my denominator. For each, it is not going to change. Each of these models is split into fourths. So I know that for my improper fraction, my denominator is going to be 4. And I know that in my mixed number, my denominator is also going to be 4. Because I am not changing this model at all. Each of these models is split into 4. When I come over here to my improper fraction, I want to know how many shaded parts I have all together in my fourths. So I have 1, 2, 3, 4 fourths here, plus another 1, 2, 3, 4 fourths. 4 plus 4 is 8 fourths, plus another set of 4, 9, 10, 11, 12 fourths, and then 13, 14, 15. I have 15 fourths because my model is in fourths, and I have 15 shaded parts. Going over to my mixed number, I'm going to look for my whole number, which is the number of whole fractions shaded in. So I have 1, 2, 3 wholes shaded in, plus 1, 2, 3 of 4 parts remaining. So 15 fourths because my model is split into fourths, and I have 4, 8, 12, 13, 14, 15 shaded in, and 3 3/4 because I have 1, 2, 3 whole models shaded in, plus 1, 2, 3 out of 4 of another.